Factoring a perfect trinomial. When I have an expression that the first term and the last term are both perfect squares, meaning that I can take the square root of them and get a nice number, I think that it might follow the perfect trinomial pattern. When I have, let's say, two numbers, in this case maybe I'm going to have a subtraction sign in the middle. The reason I'm saying that is because I can see that there's a negative sign here in the middle. When I square a minus b squared, I get a squared and I get b squared. And then we multiply the two terms together and we double them up. So minus 2 times a times b. Looking at example A, if I take the square root of the first term, I would get 7x, and I take the square root of the last term and I would get 1. I know it's a perfect trinomial if I multiply these two items together and double it, and I end up getting this middle term, which I do. 7x and 7x would give me a 14x. The only thing I need to keep track of is that there's a minus sign for the middle term, so that means that my overall answer is going to have a negative sign. So I think that my answer here is going to be 7x minus 1, the quantity squared. Going on to example B, the first term, 121x squared, if I take the square root of that, I'll get 11x. For the last term, the square root of 16 is 4. In the middle term, I have a positive number, so that means everything's going to end up being positive overall. And I just want to double check. If I do 11x times 4, that gives me 44x, and if I double that, I do get the 88x. So this is a perfect square trinomial. So the square root of the first term goes here, in the first space, 11x, and in the second term, the square root of the last goes here. All right, example C. The square root of m squared is m. The square root of 100 is 10. When I multiply these together, I get 10m, and doubling that gives me the middle term. Notice that it's a minus, so that means that I'll have a minus sign in the middle of these two terms.